Hi guys, welcome to the last part here of lecture 3, where we'll be talking a little bit about how and when it's appropriate to use some shortcuts or maybe just partial tables. And this is really connecting back with what we talked about in the previous part with regards to the semantic concepts. So, what we know is that, right, we can use truth tables to assess whether a sentence is a tautology or a contradiction, whether some sentences are tautologically equivalent, things like this. But we can think about how much of a table we really need in order to assess some of these things. So if we want to show that a sentence is a tautology, we need to generate a complete table. Right? And that's because we need to show that on every valuation, the sentence is true. For the flip side, though, to show a sentence isn't a tautology, we only need a single line of the table, just one valuation, specifically one valuation where the sentence is false. Because if there's at least one valuation where it's false, it ain't a tautology. Same reasoning, to show that a sentence is a contradiction, we need to have a complete truth table, because we need to show that in every valuation, the sentence comes out false. But to show a sentence isn't a contradiction, we only need a single line on the table, namely just one line where it's true. This means that if we're allowed to, right, so if, for example, a question on the midterm says, show whether a sentence is a tautology or not, if you want to show it's not, you can give me a truth table with just one row. Similarly, when we think about tautological equivalence, to show that two sentences are tautologically equivalent, we need a complete table, like what we did with our example in the previous section. But to show that two sentences aren't equivalent, we only need a single valuation, i.e. one row, where they differ in truth value. This is handy because it'll save us a whole bunch of time from doing a complete table. Similarly, to show that some sentences are jointly consistent, we only need a single valuation, namely one where they're all true. And to show that they're inconsistent, we're going to have a complete truth table, right? Because they're only going to be jointly inconsistent if on every valuation, we can't make them all true. Finally, when we're thinking about validity or invalidity, right, to show that an argument's valid, we're going to need to generate a complete table. To show that an argument's invalid, we only need a single valuation. Specifically, a single valuation where all the premises are true and the conclusion's false. Right? And the same thing will go with tautological entailment. To show that some sentences tautologically entail another sentence requires a complete table. To show they don't, just a single valuation where our former are all true and the latter is false. It's helpful maybe to look at a couple examples to get a feeling for how these partial tables work. Right? So just to kind of spell this out, when we're trying to assess whether a sentence is a tautology, if we want to show it is, we've got to have a complete table. If we want to show it's not, we just need one line, one row. Same thing for a contradiction. Same thing showing some sentences are equivalent. To show that they are, we've got to go through every valuation. To show that they're not, we only need one where they differ. When we think about whether some sentences are jointly tautologically consistent, to show that they are, we only need one line. To show that they're not, and hence that they're tautologically inconsistent, we need the full table. Right? Because this is the only way to show that there's no valuation that makes them all true. Similarly, when we think about validity or tautological entailment, to show that an argument is valid or that a tautological entailment relation holds, we need to have the whole table. To show that it's not, we just need one valuation where our premises are true and our conclusions false. So let's go through an example to kind of highlight this, right? Let's take our two sentences. We've got B and D, and A if and only if A or C. And I want to ask, are these two tautologically equivalent? So to answer this with a complete table is going to take a 32-row table. And that's a lot. That's way too much. But to show that they're not, we only need one valuation. So let's see if we can come up with one valuation to show that they're not equivalent. And hence, instead of writing out 32 row table, we can just do it in one, saving ourselves a lot of time and effort. So how would we do this? Well, what we need is we need a case where one sentence is true and the other is false. And we can do this either way, but let's just suppose what we're going to try and do is make our first sentence false and our second sentence true. Okay, so we fill in like the relevant value we want under the main operator for our two sentences. Okay, now looking at our two sentences, what can we do with regards to assigning truth values to A, B, C, and D that's going to help us get these? Well, let's look at our first one first, right? This one seems pretty easy. How is it that we can get a false under this conjunction? Well, look, if at least one of our two conjuncts is false, then this is going to be false. But of course, right, if we make them both false, cool. We've now guaranteed that this is false. So far so good, right? Again, the thought process, what we did, we wrote out our sentences in our truth table. We assigned false to this and true to this, and then we worked backwards to figure out a way to make this false. And the easy way to make this false is to make both conjuncts false. So now we're halfway to evaluation, because we can take the values we worked backwards to get to here and build them into our one row. So if B and D are both false, then our first sentence is going to be false. Cool. So now let's turn back to this sentence, right? So we said if we want to show that these two aren't tautologically equivalent, we need this to be true in the case where this is false. So how are we going to get this to be true? Well, it's a biconditional. And remembering what we learned with our characteristic truth tables for biconditionals, biconditionals are true as long as its two sides have the same truth value. So one side here, right, is just the atom A, and the other side is our disjunction. So this one seems pretty easy, right? We can just fix the truth value for A directly. We can either make it true or we can make it false. So really, in order to get this true, we're going to have to figure out how to make this part true. But of course, how do we make this part true? Well, this is going to be true when at least one of these two parts is going to be true. So suppose we assign true to A. Okay, cool. So we've secured truth over here, and we're going to have this be true as well. And this is only going to be true when at least one of its two parts is true. Well, hey, if A is true, right? Because remember, this one depends on these two parts. If A is true, then this is going to be true. And of course, right, we can also have C be true if we want. That's double guaranteeing this disjunction is true. Right? So what do we have now? We've guaranteed that this is true by making A true and C true. We can work backwards. We've worked backwards to figure out ways to assign truth values to A and C to guarantee that this sentence has the truth value true. We can fill these back into our matrix, and look what we have now. Right? We've got a single valuation that gives us this sentence being false and this sentence being true, and hence proves that they are not tautologically equivalent. And instead of a 32-row truth table, we did it in one row by working backwards. So again, it's sort of handy. Note, you will never have to use this sort of partial table. This is something you can do if it makes things easier. Of course, we could have brute forced this. We could have filled out the whole 32-row table and then figured out that this valuation would work. But we saved ourselves some time by thinking it through, working backwards to a valuation that gives us a different truth value for our two sentences. That's pretty nice. So let's ask a slightly different question. Let's use our same two sentences, right? We know that they're not equivalent. They know that they're not tautologically equivalent, but are they jointly tautologically consistent? Well, here again, right? At first glance, we might think we'd have to put out a whole table, but we don't have to. To show that these sentences are jointly consistent, all we need is one valuation that makes them both true. So what are we going to look for? We're going to look for a single valuation that gives us a true here and that gives us a true here. So note, very helpfully, we already know at least one assignment, one valuation that makes this sentence true because we did it in the previous example. So if we make A and C true, then this sentence is going to come out true as well. So cool, we're halfway there. Now the whole trick is, what do we say about this one? How can we make this sentence true? Well, we want it to be true. So now the trick is, let's work backwards. When is a case when this is going to have the truth value true? Well, it's a conjunction. And we know that the only time a conjunction is true is when both conjuncts are true. So when is this sentence going to be true? When B is true and D is true. So what's a valuation then that makes both of these sentences true and that shows they're jointly consistent? If we assign true to A, B, C, and D. Right? We now know this valuation makes both of our complex sentences true and hence shows that they're jointly consistent. Because there's at least one valuation where they're both true, they're jointly consistent. And we did all this without having to bother doing the huge truth table that we would generate if we did a complete table. I hope, again, this is kind of clear how we can use this sort of thinking through how the tables work to help save us some time. Note, you can always on exams, homework, anything, use complete tables if you want, right? The brute force method works, which is nice. But sometimes you can also save yourself some effort. Good. So the other thing that's helpful, because if you remember, right, we talked through and I said there are some cases, for example, if we're trying to show an argument's valid, where we'll need a complete table. So we can't do the kind of, partial table thing that we just did. But even in those cases, we can use some shortcuts. And this we can see clearest when we think about validity. So when we're checking for validity, we're really only checking for bad lines. That is, valuations, lines, where the premises are all true and the conclusion's false. So there's some things that immediately follow from this, right? Any line where some premise is false isn't bad. Right? Similarly, any line where the conclusion's true isn't bad. So remember, bad lines are ones where all the premises are true and the conclusion's false. If we can find any bad lines like that, then we know the argument's invalid. But if there aren't any bad lines, it's got to be valid. Now, when we think then about constructing our truth tables, this means we can save ourselves some effort. Right? That is, if we're kind of working through a row or a valuation, and we find a line where the conclusion's true, we don't need to evaluate it further. It doesn't matter. Similarly, if we find a line where one of the premises is false, we don't need to evaluate it anymore. It doesn't matter. We can just stop looking at it. That is, when testing for validity or tautological entailment, you can look just at the relevant lines in the table. Lines where the conclusion's false, and try and see if you can make all the premises true. So this is, again, clearest if we think about an example. So let's take an argument here, right? We've got two premises, and we've got our conclusion. Premise 1, A or B. Premise 2 is it's not the case that B and C, and our conclusion is A or not C. Right? So we can plug this into a truth table, right? We write our sentences, our premises, and our conclusion. We make sure that they're separate on the table so that we don't mix them up. Each atom gets a column. Each operator gets a column. And we're careful with our bracketing. Now, first move, always with these truth tables, is we fill out, right, the kind of matrix here with all the possible valuations. So we fill that in, right? And again, the easy way to do it, we fill true, false, true, false, true, false, true, false for a rightmost one, double true, double false, double true, double false for a middle one, and then 4 trues, 4 falses. This gives us our full matrix, all the valuations. Now, where do we go next? So we're trying to assess whether this argument's valid. And remember, the way we do that is we look to see if there are any bad lines. Bad lines are ones where the conclusion's false and the premises are true. So this suggests the best place to start. The best place to start is with the conclusion. So when you're doing truth tables, evaluating things like an argument for validity, always start with a conclusion. Right? Here's why. So we're going to do the conclusion. Right? What's the first thing we do? Well, we pop in our relevant columns, so C and A under their occurrences. So far, so good. And our next step, if we're just looking at the conclusion, is going to be our negation here. Right? And looking at our characteristic truth table for negation, we know what to do. It flips. So whenever there's a T, we write an F. Whenever there's an F, we write a T. So far, so good. Right? And now our next step is to evaluate the disjunction. Right? And it's going to be looking at these two columns. And again, disjunctions, how do they work? Well, if at least one of the two disjuncts is true, then the disjunction's true. So it's going to be true, 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 false, true, false, true. Okay? Now, remember, what we're looking for is whether this argument's valid. And the way we assess it is by finding bad lines. So what we want to look at now are just the two valuations where our conclusion's false. Okay? Why? Because we'll know the argument's valid if there are no valuations where the premises are all true and the conclusion's false. So we found the valuations, and in fact the only valuations where the conclusion's false. And we're now going to try and see if on these two we can make the premises true. If in either one of these two, both premises are true, we'll know the argument's invalid. And if in both of these, it turns out that at least one of the premises is false, then we'll know the argument's valid. Because these are the only times when the conclusion's false. Right? So what do we do next? Right? Again, we just focus on these two. We don't care about the other lines in this table. The other rows don't matter. We just look at the two rows where our conclusion's false. So these two valuations, these are the important ones. So let's look and see with regards to, say, our first premise, what do we do in these two valuations? Okay. So on our first sentence, right, our first premise, it's got a disjunction. And in this valuation and in this valuation, right, it's going to lean upon A and B, and A and B. And of course, in this case, what's it going to be? Well, at least one of our disjuncts is true. Right? So we can carry these over. In this case, at least one of our disjuncts is true. So that's going to be true. And in this case, neither one of our disjuncts is true. So this is false. So on this valuation, where we have a false conclusion, at least one of the premises is false. So we no longer have to pay attention to this line at all. It can't be a bad line, right? Because bad lines are ones where all the premises are true and the conclusion's false. In this line, it's not the case that all the premises are true. So we're now down to just doing this one, which is great. We've saved ourselves a whole lot of time. Look at all that real estate. We didn't feel it. Right? So cool, right? We look, in this case, one premise is false, so we don't have to worry about that line anymore. We're just looking at this one now, which is cool. So now, right, we know which valuation to focus entirely on with regards to looking at this sentence. And this is going to be our main operator for this sentence, right? Because it's a negation of a conjunction. So what truth value this is going to have, this spot right here, is going to be determined by the truth value that we fill in here. And of course, right, what truth value, right, this is going to have is going to be determined by what truth values these two parts have. So now what truth values do we put in here? Well, for B, we're going to put T, and for C, we're going to put T. Both of them are true on this, the only valuation that matters. So we fill in the T, we fill in the T. So far, so good. Now, of course, right, with a conjunction, if both conjuncts are true, we know what truth value the conjunction takes. It's true. Cool. And of course, right, we now have the information we need to fill in this spot, because it's negation of this conjunction. And what does it do? Well, if we put in a T, negation flips, so it becomes an F. And hey ho, what do we get now? Right? Well, if we look at this one valuation, we've got a false conclusion, but one of our premises is false. So there's no line, there's no valuation where all the premises are true and the conclusion's false. So we can conclude this argument's valid. Right? And why is it valid? Because there's no way, right, for all the premises to be true and the conclusion false. Because in each case, at least in each case where the conclusion's false, at least one of the premises is false as well. So there we go, right? And we saved ourselves a lot of time. Instead of filling in every single spot, right, we filled in the conclusion. We found the spots where the conclusion was false. Then we figured out in those cases, and in only those cases, whether the premises are true and false. So instead of filling in all of these boxes, we just filled in the relevant ones and helped save ourselves a lot of effort. So this is something you can use when you're doing these, right? You can use some shortcuts. So note, again, this is still a complete table, but instead of filling in every single bit of information, you just highlight the relevant bits of information. And this is something handy you can always use. Don't feel obliged to, but you can use it if it helps. Cool. So that's basically it for today. What have we done, right? We started off by looking at these characteristic notions of truth functionality and the characteristic truth tables for our connectives. We then used those to to move into thinking about complete truth tables, which is this beautiful sort of brute force mechanism for doing all sorts of things, right? We can now tell whether some sentences are tautologies, which are close to necessary truths, contradictions. We can find out whether some sentences are jointly tautologically consistent or inconsistent. We can now determine whether some sentences are jointly tautologically equivalent or not. But more importantly, we've got this notion of tautological entailment that helps us understand validity. Right? So we've now got a great tool to evaluate whether arguments are valid or invalid in this pure brute force kind of truth table way. That's really cool. So that's a nice upshot. And we did it in 3 weeks. So good job, guys. But of course, right, TFL's great, but it's limited. And we've tried to highlight a couple times some of its limitations. So what we're going to do next is we're going to turn to our second formal language. And this is first order logic. So first order logic uses all of the stuff that we've talked about and just makes it better. It's more expressively powerful. We can say and do a lot of things that we couldn't do in TFL. So for the next lecture, please read pages 54 to 72 for all X, the homework. Take care, guys. I hope you've enjoyed these, and I look forward to talking about this stuff with you on some Monday. Bye.